Bismillahirrahmanirrahim. Students, welcome to visual session of week 9 of Database Management Systems course. If you can hear me properly, please raise your hands. Okay. So let me share slides with you. Okay, the format of today's session will be as before. Like first, I'll be giving you a lecture. I'll continue from where I left in our face-to-face session, and after that, you can ask me questions. So we were talking about database recovery techniques in our face-to-face class. The purpose of database recovery is to bring your database in the last consistent state prior to the failure. Like before a failure occurs, before a crash occurs, there is a consistent state. So when you recover database, we are bringing a database in the previous consistent state. Another purpose is to preserve the transaction properties. For example, if the system crashes before a fund transfer transaction completes its execution, then either one or both accounts may have incorrect value. So we need to restore both of these accounts. I told you in previous lecture in our face-to-face class that there are certain errors or certain failure scenarios in our databases, such as system crashes and transaction errors. So we need some recovery mechanisms. And we have already talked about recovery mechanisms such as commit points and system logs. So first of all, we need to know what are the different types of failures which can occur. The database may become unavailable because of three types of failures: transaction failure, system failure, and media failure. And transaction fails because of some input incorrectness, deadlock, or because of some synchronization errors. And the system failure means the system is failing because of some addressing error, application error, or operating system errors. And the media failure is of the kind when your database is not functioning properly because of some disk head crash or power disruption or other errors. For recovery from any type of failures, we need to maintain a log, and this is a typical log, transaction log, which is maintained, where we have all the transaction IDs, their previous value, their next value, and the previous log entry and next log entry, the operations and the content of the data item, and BFIM and AFIM are indicating before image and after image. So before the transaction was logged, the value of X was 100, and after it was logged, that value of X is 200. So at any point of time when we need to restore it, we can restore the values of AFIM with the value in BFIM. The data updates are of four types: immediate update, deferred update, shadow update, and in-place update. And immediate update is that as soon as the data item is modified, the disk copy is also updated. Deferred update is the one when we write all the modified data items to the disk after some transaction ends or after the certain number of transactions have ended. So we wait for some time. And shadow update is the one when we do not write the modified data items into the actual disk space. And in the development we have a shadow of that, and we write it in a separate disk location. And in-place update is a disk version of data item is overwritten by the cache version. So when we are modifying the original data item, then it is in-place update. Data items for recovery, we maintain a cache of items in databases, and we store them in a cache, and which is managed by Cache Manager. Just like when we are using, we are managing the operating system. The operating system keeps the pages of memory in cache, and then use some replacement algorithms and placement algorithms to utilize the limited cache and main memory. So in the same way, we have a cache manager for databases which use all the similar algorithms which are used in operating systems for maintaining the disk blocks in the cache memory. The flushing means to writing the data items from cache to the disk. The flushing is controlled by modified and pin-unpin bits. The modified bit is also called dirty bit, like as it was called in operating system. And there is a pin-unpin which instructs the operating system, like if the value of pin is 1, it instructs the operating system not to flush the data item. It means like this value has been used in a transaction which has not yet committed. So the value cannot be flushed to the disk. There is a transaction rollback and roll forward operations. And this roll back is called undo and roll forward is called redo. The roll back operation restores before image on the disk, and redo operations restore AFIMs on the disk. Then there is a recovery mechanism which is called write ahead logging. When in-place update, immediate or deferred is used, then log is necessary for recovery and it must be available for recovery manager, and this is maintained by write ahead logging protocol. Just wait for a minute. The basic purpose of write ahead logging is that like for undo operation, before a data item after image is flushed to the database disk. It means on the disk we are going to write PFIM, overwrite PFIM. So before the data item AFIM is flushed to the disk, its BFIM before image must be written to the log, and the log must be saved on a stable storage, so that whenever you have to undo, you can read the BFIM value from the log and restore it. So this is called write ahead logging protocol. And for redo operation, we have to make it sure as well. Before the transaction executes its commit operation, all its AFIMs must be written to the log, and the log must be saved on a stable storage. The stable storage means you are going to save it on the secondary storage. So this is the requirement. Now another thing which is checkpointing is important. Checkpointing means like from time to time, either randomly or after some based on some criteria, the database flushes its buffer to database disk to minimize the task of recovery. And the following steps are performed. First of all, to suspend the execution of transactions temporarily, you suspend all the transactions which are being executed temporarily. Then you force write modified buffer data to disk. Force write. So when you say force write, it means you are going to stop all operations, and before, like you know that the transaction has not committed yet, but even then you are performing force write. It means you are writing all the current values to the disk. This is called force writing approach. So you force write modified buffer data to disk, write a checkpoint record to the log, save the log to disk, and then you resume the normal transaction execution. And during the recovery, redo or undo is required to transactions appearing after checkpoint record. So this is checkpointing, and checkpointing is very important. A form of checkpointing is also called, I don't know whether the details are here or not. Okay, maybe they will be mentioning later. Then there are possible ways for flushing data items, flushing database cache to database disk. The possible ways are steal, no steal, force, or no force. So when you say steal, it means cache can be flushed before transaction commits. This is called stealing. And if cache cannot be flushed before the transaction commits, this is called no stealing. Like if the before the transaction has committed, you cannot write the cache buffer content to this. It means no stealing. You cannot steal the data which has not yet committed. And it means, steal means like the transaction is not yet committed, but you can steal the data and write it on the disk. And then the force approach is cache is immediately flushed to the disk, and no force means cache is deferred until transaction commits. These give rise to 4 different ways of handling recovery. Like if there is steal and no force, if there is steal and force, if there is no steal and no force, no steal and force. These 4 combinations. So there are 4 different ways which occur, and we have to have recovery mechanisms for them. So when there is no undo and redo, which is called deferred update, the data update goes as follows. A set of transactions record their updates in the log. At commit point under write ahead logging scheme, these updates are saved on database disk. After reboot from a failure, the log is used to redo all the transactions affected by this failure. And no undo is required because no after image is flushed to disk before a transaction commits. So this is the the no undo scenario of a deferred update. Deferred update in a single user system, when there is no concurrent data sharing in a single user system, the data update goes as follows. The set of transactions record their updates in a log, and at commit point, these updates are saved to database disk. And the deferred update scenario, when there are concurrent users, look like this. We require some concurrency control mechanisms as well, because in case of concurrent users, we want to ensure the isolation property of transactions as well. In a system recovery transactions which are recorded in the log after the last checkpoint was redone, the recovery manager may scan some of the transactions recorded before the checkpoints to get after image. Now this is an example of the recovery timeline to illustrate the effect of checkpointing. Now you can see here that the time is moving in this direction. Now transaction 1 is executing, and meanwhile the transaction 3 and 4 have started. So you have maintained a checkpoint over here, and after this, after some time, at time T2, the system crashes. So you need to recover the operations you have performed between time T1 and T2, which you can recover from the log. And all the data which was performed before checkpoint T1 can be retrieved from the disk. Now for deferred update with concurrent users, you require 2 tables to implement this protocol. These 2 tables are active table and commit table. Now this active table contains all active transactions, and this commit table contains the table contains transactions to be committed. It means the transactions which are ready to be committed are contained in the commit table, and the transactions which are executing are placed in the active table. During recovery, all transactions of the commit table are redone, and all transactions of the active tables are ignored, since none of their AFIMs reach the database, because the database has not received the AFIM so far. It is also possible that a commit table transaction may be redone twice but this does not create any inconsistency because of a read-on is idempotent. Because even if you perform an entry of commit table, repeat the entry of commit table twice, it doesn't matter because you will be repeating the same operation another time. Like you have overwritten an item, if you overwrite it again, it doesn't matter. And when I say that the read-on is idempotent, it means no matter how many times you perform this operation, it will give you the same result. That is, one read-on for an AFIM is equivalent to multiple read-on for the same AFIM. Now this is a recovery technique based on immediate update, which is undo no redo algorithm. In this algorithm, after image of a transaction are flashed to the database disk under write ahead logging before it commits. So after image of a transaction are written to the disk because you are following write ahead logging. For this reason, the recovery manager undoes all the transactions during recovery, and no transaction need to be redone because you have already flushed the values to the database disk. Now, undo redo algorithm in single user environment. Apply undo and redo for recovery, and because there is no concurrency control needed because it's a single user environment, so you can maintain a log, and at any time there will be one transaction in the system. It will be either in the commit table or in the active table. So undo of a transaction if it is an active table, and you perform redo if it is in the commit table. For single user system, it's very easy. And for immediate update in case of concurrent execution, now this scheme applies undo and redo as well to recover from the failure. A concurrency control is required as well, and you are also maintaining logs using write ahead logging. And commit table record transactions to be committed, and active table is as well recording active transactions. But in case of concurrent executions, you require checkpointing. Now, another database recovery technique is shadow paging. That is a recovery scheme. This recovery scheme do not use logs in single user environment. However, we can have logs in a multi-user environment. So what we do in this case is that we say that our database is made up of number of fixed size disk blocks. The AFIM does not overwrite its before image, but record it at another place on the disk. So you are maintaining another copy of the data item on the disk. At any point, the data item has AFIM and BFIM shadow copy of the data item at two different places of the disk. So you are having two different copies. X and XY are shadow copies of data item, that X prime and Y prime are current copies of data item. And you maintain a current directory and a shadow directory as well. So the directory management is illustrated in a figure 23.4 in your book, which you can see from there. It's in the same way because there's the current directory, and you record that where you have placed on the disk, and you also maintain a shadow directory, which also keeps the record of that where the shadow is the content which are not updated, which are the original content, and then the current contents are also maintained in a current directory. Now this is a Aries recovery algorithm. This algorithm is excluded from your contents, from your course contents. All of the instructors have decided to exclude it because it is not mentioned in the learning outcomes of this week. So this is excluded, but you need to know the basics of this. Like you need to just have an idea about it, that this Aries recovery algorithm is based on write ahead logging, and you repeat history during redo, and you log changes during undo. That's all about it. You don't need to know more details about it. Now, recovery in multi-database systems. A multi-database system is a special distributed database system where one node may be running relational database systems under Unix and another may be running object-oriented systems under Windows and so on. So this is a multi-database scenario where you are running different forms of database in different operating systems. Transactions may run in a distributed fashion at multiple nodes. In this execution scenario, the transaction commits only when all these multiple nodes agree to commit individually the part of the transaction they are executing. And this commit scheme is referred to as two-phase commit, and which is called 2PC. If any one of these nodes fails or cannot commit the part of the transaction, the transaction is aborted. It means all of them should commit so that we can commit that transaction. And each node recovers the transaction under its own recovery protocol. So everyone is responsible for the recovery on its own. Okay, that's all. Okay, then our lecture is over. Now you can ask questions if you have any in your mind about it. Any questions? Okay, now I'm closing the slide and turning my microphone off, but I'm available. If you have any questions from this week's content, you can ask me in the chat panel. Thank you very much.